Okay, so let us start the next set of instructions then. So my printer isn't working properly, so half of it didn't come out, but that's my next thing to learn, is how to redo the printer cartridge. Okay, so I'm just going to go with it as it is because you can see what it means. The first question said calculate the relative formula mass of calcium carbonate, and you're given the atomic masses. You are also given in the box at the top there the fact that it's CaCO3, so therefore I've got Ca40 plus carbon, which is 12, plus 3 lots of 16, which adds up to 100, so the relative formula mass of 100. And then it asks me what percent of calcium is there in calcium carbonate. So calcium is 40, the whole of calcium carbonate, as we just worked out, was 100. So as a percentage, that is 40% calcium. It then says calculate the mass of calcium in each tablet. So back on the label there, it tells me that a tablet is 1.25 grams. So therefore 40% of that is calcium. So 40% of 1.25 is 0.5 grams. Next question is an unwanted side effect of the medicine is it can cause gas. Why? And you can see there that the reason is that carbon dioxide is one of the products and carbon dioxide is a gas. Okay, next question. That's going to look smeary. Oh, here we go. Next question. So, I've lost my place. Here we go. So the next one, back again to calculating relative formula mass. So I'm given that it's FeSO4, and therefore, and it's not printed out on mine, but you're given the relative atomic masses. So Fe is 56 plus S, which is 32, plus this time 4 lots of oxygen. Add that together and you get 152. So it then asks me what the mass of 1 mole would be. So this is just testing the fact that you know the mass of a mole is the relative formula mass in grams. So it's the grams there that we're looking for. So then the next question, what mass of iron sulfate would I need to provide 28 grams of iron? So iron sulfate altogether is 152 grams, we decided. Of that, 56 grams is due to the iron. It's telling me here that I've got 28 grams, which is half of that. So therefore, if I divide that by 2, I'll get how much iron sulfate I would need, which is 76 grams. Okay, next. Test for hydrogen gas is a lit splint, and the result would be a squeaky pop, or you could just have a pop, or explosion. Why does magnesium need to be heated to start the reaction? Well, it provides energy for the reaction. To break bonds is the second mark, or just for 1 mark, the activation energy is worth 2 marks altogether. We've got an equation for the reaction. The teacher used 1 gram of magnesium, so we're doing a reactive mass calculation to find out the maximum mass of magnesium oxide you could make. So 1 gram of this would make how many grams of that? So magnesium weighs 24, its relative formula mass is 24, so from 24 the relative formula mass of magnesium oxide is 40. So therefore I can use my mass over Mr. Mole triangle, if that's how you prefer to think of it, and say, okay, so how many moles have I got? So I haven't got 24 grams of magnesium, I've got 1 gram of magnesium. How many moles is that? So how many moles is the mass divided by the molecular mass? So therefore it's 1 divided by 24 is 0.04 moles of magnesium. So 1 mole weight makes 1 mole, so therefore 0.04 moles of magnesium would make 0.04 moles of magnesium oxide. How much would that weigh? So if I'm trying to find out mass, I need to do the molecular mass times the moles. So it's 0.04 times 40 is equal to 1, or I've fallen off the bottom of the paper. It's not good when you're not someone I've fallen off the bottom of the paper. 1.6 recurring, but it's asked for it to 3 significant figures, so 1.67 grams. Next. So, the teacher's demonstration actually made 1.5 grams. What's the percentage yield? So the percentage yield is the final amount divided by the original amount times 100. So I got 1.5 divided by 1.67 times 100. So it's 89.8% or 90% yield. Why is it less than 100? There are various reasons. It could be that not all were reacted. It could be a reversible reaction. There could be some magnesium oxide left in the tube, and there could be an unexpected reaction. I'll post the mark scheme so you can see those options. Formula for a chemical compound magnesium sulfate. I'm getting the relative formula mass yet again. So it's 24 plus 32 plus 4 lots of 16. That's 120. Magnesium sulfate can be made from magnesium and sulfuric acid. This is a reacting mass calculation. 4 grams will make how much magnesium sulfate? So what are my formula mass, molecular masses? 24, and that's 120 just by adding together magnesium, sulfur and oxygen. So again, I'm back to mass over Mr. Mole. How many moles have I got? So 4 grams, 1 mole would weigh 24 grams, so how many moles have I actually got? So I'm calculating moles, so it's mass, 4 grams divided by the molecular mass, 24, which is equal to 0.167 moles. Okay, 1 mole of that would make 1 mole of that, so therefore I'd make 0.167 moles of this. How much would that weigh? Mass, molecular mass times the moles, 120 times 1.67 is equal to 20 grams. Nearly there, final question. Iron, commonly used metal in the blast furnace. I'm told that a sample of iron ore contains 70% iron. It's 2,000 tonnes of it. So 70% of 2,000 is 1,400 tonnes. So therefore, how much iron could be extracted from that 2,000 tonnes? So first I just need to check the equation's balanced. It's not. I need a 2 in front of the iron. Next I need to work out my masses. So therefore, it's saying I've got 2,000 tonnes of hematite, which I've worked out is 1,400 tonnes of iron oxide, and it's asking me how much iron could I make. So how many moles of iron oxide have I got? Well, if I add up iron, 2 irons and 3 oxygens, the molecular mass is 160 and the molecular mass of iron is 56. So mass over Mr. Mole. Okay, so how many moles have I got? Mass over molecular mass. 1,400 divided by 160 is 8.75 moles. So 1 mole would make 2 moles, so I would make double it. So times that by 2, I'd make 17.5 moles. How much would that weigh? Mass is molecular mass times the number of moles is 980 tonnes. Excellent. Okay, I will see you next week. Have an enjoyable weekend. Do what you can. Okay, bye for now.